Let's get these implicit differentiation common mistakes videos wrapped up today. My last couple videos, I've been talking about common mistakes that I see a lot of students, including myself, make when they are solving implicit differentiation problems. Of course, making mistakes is part of the learning process, so it's gonna happen. But I really want with this series to kind of help reduce that learning process and help you get the right answer quicker and more often. If you want to check out those first two videos where I talked about getting the problem set up and then the actual differentiation step of implicit differentiation and how to avoid common mistakes in there, I'll put an info card right up there so you can go check those out. But today I'm going to be talking about how to finish the problem, just kind of the final steps that you want to go through to get to the answer, and more specifically talking about common places that I see people go wrong, because I have made lots of videos showing you the correct way to do implicit differentiation problems, but I want to take a little bit of time to kind of point out common mistakes so that you can look out for those yourself and avoid making them when you think you want to do it the way that a lot of people kind of do incorrectly. So anyway, let's go ahead and jump into the final bit of this process so you have these mistakes on your radar so you can avoid them yourself. Let's go ahead and jump on into it. That is pretty much the main mistakes I see in those first two steps. Just to kind of quickly touch on this third step here, in terms of common mistakes that I see. Really, the most common mistake that I see come up in this third step here mostly stems from people not doing one of these first two steps properly. And it kind of snowballs and leads to problems in this third step here. And the reason I kind of say that is, when you're trying to solve for dy dx, basically the idea is once you have, properly taken the derivative of both sides of your equation with respect to whatever your variable is, if we're trying to find dy dx, then with respect to x, like I was kind of talking about over here, at that point, what you would basically end up with is, a bunch of terms being added and subtracted to each other, where there's going to be terms that have dy dx's in them, and then there's going to be terms that don't. So essentially, wherever we had a y in our original equation, those terms typically are going to end up kind of contributing to having dy dx's after you take the derivative in your second step. Now, it could also create terms where there's y's but not dy dx's. That's fine. You really just want to kind of keep track of. What I like to do is just kind of, obviously I have the benefit of multiple colors here on this board, but when I get to this third step, what I like to do is just circle all of my dy dx terms in one color, and then circle all my terms that don't have a dy dx in them in another color, so that it's easy to see which things I need to kind of add or subtract over to the other side. So what I mean by that is, let's say after taking the derivative of both sides with respect to x, I end up with something like, and this is not going to be the same as the equation we had up here. This is not necessarily what this would lead to. I'm just kind of creating a new example out of thin air just to kind of prove a point about this step here. Let's say we have something like x, y minus dy dx times sine of x equals x dy dx plus 16. Let's just say, for example, you can see basically, and when I say term, what I mean is a bunch of little, letters or symbols that are being multiplied together is one term. So we have one term here, x times y. We have one term here, minus dy dx times sine of x. We have one term here, x times dy dx, and then we have one term here, plus 16. Okay, so just kind of separate out what are your actual terms, and then what I like to do is any that have a dy dx in them. So you can see right here there's dy dx, I circle one color. Right here there's a dy dx, I circle that same color. Okay, and then I circle in another color the terms that don't have a dy dx. So in this case, there's no dx or dy dx here, there's no dy dx here. Okay, so you've kind of figured out which things need to be on one side of the equation, which things need to be on the other side. And then from there, since how I've defined a single term is stuff that's being added or subtracted together, we should be able to just add or subtract all of our terms over to the other side of the equation that need to be moved. So basically, we could just minus this term over to the right side. Whatever you do to one side of your equation, you have to do to the other side. But what that'll do is it'll cancel over on the left. And then we could minus our x dy dx from both sides of your equation. Whatever you do to one side, you have to do to the other side, but it'll cancel over here. And then we would have these two terms with a dy dx on our left side, so minus dy dx times sine of x minus x dy dx equals minus xy plus 16. So then you can see all of your dy dx terms, all of your dy dx terms are now on our left side of our equation, and all of our non-dy dx terms are all on the right side. You know, when I say a common mistake that I see people make a lot in this one, really just comes from kind of having an overcomplicated situation here due to not doing the first two steps correctly, because it's fine that we have x's and y's and dy dx's all at this point. That does kind of freak a lot of people out. They think they made a mistake because there's still x's and y's, and then there's also this dy dx mixed in there too, and it seems so much more complicated, but that's fine, right? Your final answer for these questions is typically going to be a dy dx equals something with x's and y's in it over on the other side of the equation. So it's fine that there's x's and y's all mixed together, and now there's these extra dy dx's. It seems like it's impossible to solve for them, but it's not. All you need to do is think about how to add or subtract all of your dy dx's to one side of your equation, all of your non-dy dx's to the other side. And then after that, it should be pretty straightforward to do this fourth and fifth step. There's typically not going to be, much room for error here, because once you've gotten through the third step pretty well, all you have to do is factor out a dy dx out of your side that has dy dx's in it, which basically what that does is it reduces your equation down to a situation where you only have a single dy dx times a bunch of other stuff. And then to isolate the dy dx, all you have to do is divide that bunch of other stuff that's being multiplied by dy dx, divide it over to the other side of the equation. Thanks for sticking around to the end of this video, and the end of this 3-video series actually. If you did find it helpful, do me a favor, hit that subscribe button and that bell icon, and hit that like button as well, that thumbs up button right down there. Those are all a huge help to my channel, so I can keep making more videos like this, and we can keep crushing it all term long in calculus. If you want to keep learning about implicit differentiation and the steps to solve an implicit differentiation problem, I'll go ahead and put some videos over there for you to go check out. So go click over there and let's keep this brain train rolling. Thanks, and see you next time.